In 2009, astronomers were watching a massive star, 25 times the mass of our sun, burning bright, expected to explode in a spectacular supernova. Then one day, it just disappeared. No explosion, no debris, no radiation burst. One moment it was there, the next, nothing. They checked their instruments, recalibrated, searched with different telescopes. The star was gone. And this isn't the only time it's happened. Across the universe, objects are vanishing. Stars, galaxies, entire supernovae, disappearing like glitches in reality. And we have no idea why. The star that became a black hole without exploding. Let's start with the most famous case, N6946-BH1. This star was located in the Fireworks Galaxy, a galaxy known for frequent supernovae. Scientists were monitoring it because they expected it to explode any day. In 2009, it began brightening. This is normal pre-supernova behavior. The star's core was collapsing. Fusion was failing. Any moment, it should detonate. But then something strange happened. The star's brightness suddenly dropped, and over the next few months, it faded and faded until it was gone. At first, scientists thought it was hidden behind dust, but infrared observations, which can see through dust, showed nothing. The star had vanished. Here's the leading theory: failed supernova. Instead of exploding, the star's core collapsed so rapidly that it formed a black hole before the outer layers could be blown away. The black hole immediately swallowed everything: the outer envelope, the shock wave, the light, everything. In seconds, a 25 solar mass star became a black hole. Silently, invisibly, no explosion, no supernova remnant, just gone. But here's the disturbing part. If this can happen to one star, how many others have quietly disappeared? How many black holes exist that we never saw form? The 100 vanishing stars. In 2019, a team of astronomers decided to compare old sky surveys with modern observations. They wanted to see if any stars had disappeared. They analyzed millions of stars, and they found 100 objects that were present in old images but completely absent in new ones. No explanation, no nearby supernova remnants, no visible companions that could have eclipsed them, just gone. Some of these stars were bright enough to be seen easily. They weren't faint objects on the edge of detection. They were obvious. And now, they're not there. Possible explanations. 1. Failed supernovae, like N6946-BH1. Stars collapsing directly into black holes without exploding. 2. Extreme dimming events. Perhaps these stars underwent sudden, dramatic drops in brightness. But this would require mechanisms we don't fully understand. 3. Obscuration by dust. Maybe clouds of dust moved in front of them. But for 100 stars? That's statistically unlikely. 4. Foreground object movement. Maybe something in our solar system happened to block these stars in old images. But again, 100 stars. 5. Something else. The option no one wants to consider. That stars can vanish for reasons we haven't discovered yet.
The missing supernova remnants. Supernovae are supposed to leave remnants. When a massive star explodes, it ejects its outer layers at 10% the speed of light. This material forms an expanding shell of gas and dust. We can see these remnants for thousands of years. The Crab Nebula, Cassiopeia A, the Veil Nebula, all supernova remnants. But in 2015, astronomers found something disturbing. They detected a supernova, watched it brighten, watched it fade, then went back years later to study the remnant, and found nothing. No expanding shell, no glowing gas, no debris field. The supernova happened. They have the light curve data. They have the spectrum. They know it exploded, but the remnant is missing. Theory 1. It collapsed into a black hole mid-explosion. Maybe the core formed a black hole during the explosion. The black hole then swallowed most of the ejecta before it could escape. Theory 2. The remnant is there but invisible. Maybe it's too faint, too dispersed, hidden behind dust, but deep observations have found nothing. Theory 3. We're wrong about supernovae. Maybe our models are incomplete. Maybe some supernovae don't leave remnants. If that's true, then we need to rewrite stellar evolution theory. Galaxies that fade away. Now let's scale up. Not just stars disappearing, galaxies. In 2016, astronomers found a galaxy that seemed to be fading out of existence, Dragonfly 44. A massive galaxy, roughly the size of the Milky Way, but with almost no visible stars. It's called an ultra-diffuse galaxy. Most of its mass is dark matter. But here's the weird part. When they observed it years later, it had faded even more. Not just dimmed, not just obscured, structurally changed, as if it was being erased. Other galaxies have shown similar behavior. They appear in one survey, then in follow-up observations, they're gone, or so faint they're barely detectable. Possible explanations. Tidal disruption. Maybe a larger galaxy is gravitationally tearing them apart, but the models don't match the observations. Dark matter evaporation. Could dark matter somehow dissipate? We don't think so, but we don't fully understand dark matter. Measurement errors. Maybe these galaxies were never as bright as we thought they were, but multiple independent observations suggest otherwise. Cosmic glitches. The least scientific explanation and the most unsettling. What if the universe has errors? Regions where reality isn't stable. The star that blinked. In 2017, astronomers were studying a star called KIC 8462852, also known as Tabby star. It's famous for bizarre dimming events. But there's another star with an even stranger story. EP 204278916. This star dims by 80% every 24 hours, then returns to normal. But here's what's bizarre. During the dimmest phase, the star completely vanishes. Not just faint, not just obscured, gone. Below detection limits for about an hour. Then it reappears. Theories. Massive planetary ring system. A planet with gigantic rings orbiting the star. When the rings pass in front, they block 80% of the light. But the rings would have to be absurdly large. Disintegrating planet. A planet being torn apart, creating a debris cloud. Possible, but doesn't fully explain the complete disappearance. Binary companion. Another star or massive object passing in front, but no companion has been detected. Unknown mechanism. Once again, we're left with, we don't know. What this means, the universe is full of things that disappear, stars that blink out, supernovae that leave no trace, galaxies that fade away, objects that vanish as if they were never there. And every time we investigate, we find the same pattern. Our models don't predict this. Our instruments confirm it's real, but we can't explain it. Which means one of two things. Either our understanding of stellar evolution, galaxy dynamics, and cosmic mechanics is incomplete, or the universe is far stranger than we imagined. Here's the truth. The universe doesn't owe us explanations. It doesn't care if we understand. Stars will vanish. Galaxies will fade away. Objects will disappear without leaving a trace. And all we can do is watch and wonder and keep searching for answers. Because the moment we stop asking, where did it go, is the moment we stop being scientists and start being blind.